In differentiation, when we differentiate a function, f of x, so there's our function f of x, and this is a graph of it, what are we actually doing? Well, when we find the derivative, we're actually finding the gradient of a tangent. So when we differentiate, that's f dashed of x, this represents the gradient of the curve. Or, since we have a curve and the tangent at that point, it is the gradient of the tangent. So given a point where x is equal to a, and therefore where the value of the function is f of a, then f dashed at that point is the gradient of the tangent, where x equals a. And that's what we're going to be using, that the derivative, the value of it at the point where x equals a, gives us the gradient of the tangent. Because if we know the gradient of the tangent and we know the point on the curve, we can then find the equation of this tangent, because it's just a straight line. So let's have a look at some examples. In the first example, we'll take f of x is equal to x cubed minus 3x squared plus x minus 1. And what we want is the equation of the tangent to this curve at the point where x equals 3. Well, at the point where x equals 3, so the first thing we're going to find is where is this point on the curve. So we take x equals 3 and we'll find f of 3. So that's 3 cubed minus 3 times 3 squared plus 3 minus 1. 3 cubed is 27, 3 squared is 9, and 3 nines are also 27. So this builds to 27 minus 27 plus 3 minus 1. So altogether we come up with 2. So the point that we're actually interested in on the curve is the point 3, 2. Now the next thing we need is the gradient. We've now got a point on our line, on our tangent. We now need its gradient. So we need to differentiate f dashed of x. So let's differentiate 3x squared for the derivative of x cubed. Now we differentiate this term, and so that's minus 6x. Now this term, so the derivative of x is 1, and now the final term, the derivative of 1 is 0, because it's a constant. We need the gradient when x is equal to 3, so we can take that value x equals 3 and substitute it into our expression for the gradient. And so we have 3 times 3 squared minus 6 times 3 plus 1. 3 squared is 9, and 3 nines are 27. Minus 6 times 3 is minus 18 plus 1. And so this works out to be 27 take away 18, that's 9, and add on 1, that's 10. And so we've got a point and we've got a gradient. So let's write those things down. We've got our point, which is 3, 2, and we've got our gradient, which is 10. And what we want is the equation of the tangent at this point on the curve with this gradient. So that's the equation of a straight line. And the equation of a straight line that goes through a point x1, y1 is y minus y1 over x minus x1 is equal to m, the gradient. So this is our x1, y1. Let's just write that in over the top, x1, y1. And this is our gradient, m. So now we'll substitute these numbers in. So we have y minus 2 over x minus 3 is equal to 10. Now we'll multiply up by this x minus 3 here. So we have y minus 2 is equal to 10 times x minus 3. Now all we need to do is multiply out the bracket. Y minus 2 is 10x minus 30, remembering to multiply everything inside this bracket by what's outside. And now we just need to get this 2 over here with this 30. So we add 2 to both sides. Y equals 10x. Now minus 30 adding on 2 is minus 28. And there's the equation of our tangent to the curve at this point on the curve with that gradient. Okay, let's take another example. This time, let's say that what we want to be able to do is looking at this curve, y equals x cubed minus 6x squared plus x plus 3. And what we want to find are what are the tangents, what are the equations of the tangents that are parallel to the line y equals x plus 5. So here's our curve, and what we want are the equations of the tangents parallel to this line. Well, we've got to look at this line and we've got to extract some information from it. The information that we can get from it is what is its gradient, because if the tangents have to be parallel to this line, then they have to have the same gradient. And what we can see is that we've got 1x here. And the standard equation for a straight line is y equals mx plus c, where this m is the gradient. So what we gain from looking at this standard equation and comparing it with the straight line is that the gradient of the straight line m is equal to 1. So now we know what the gradients of the tangents have to be. The gradients have to be 1. So how can we calculate that? Well, we know that if we differentiate this curve, its equation, we will get an expression for the gradients of the tangents. Then we can put it equal to 1 and solve an equation that will give us the points, or at least will give us the x-coordinates of those points. So let's do that. We know what y is. Let's differentiate. dy by dx is equal to the derivative of x cubed is 3x squared. The derivative of minus 6x squared is minus 12x. The derivative of x is plus 1. And the derivative of 3 is 0 because it's a constant. And we want this expression to be equal to 1. So we can take 1 away from each side, and we have 3x squared minus 12x equals 0. And this is a quadratic equation for x, which we can solve. So let's do that. 3x squared minus 12x equals 0. It's a quadratic. The first question we've got to ask ourselves is, does it factorise? And if we look, we can see that we've got a common factor in the numbers of 3 and a common factor in the x terms of x. So we can take out 3x as a common factor. 3x times by something has to give us 3x squared, so that's got to be x, and 3x times by something has to give us minus 12x, so that's got to be minus 4, and so that equals 0. Two numbers multiplied together give us 0, so one of them has to be 0 or both of them have to be 0. So we can say 3x equals 0 or x minus 4 equals 0. So therefore x is 0 or x equals 4. Now having got these two values of x, we want the points where these tangents were. What we've got now are the x-coordinates. We now need the y-coordinates. And to do that, we need the equation of the curve again. So let me just bring back the page, and it's x cubed minus 6x squared plus x plus 3. So y equals x cubed minus 6x squared plus x plus 3. And first of all, we want the point x equals 0. And so y equals, we put x equals 0, that's 0 cubed. We put x equals 0 minus 6 times 0 squared plus 0 plus 3. Well, each of these three terms is 0, so we end up with 3. And x equals 4. Y is equal to 4 cubed minus 6 times 4 squared plus 4 plus 3 equals, well, 4 cubed is 4 times by 4 times by 4. 4 fours are 16, and 4 times by 16 is 64. Take away, now we've got 6 times by 16, and so that's 96, plus 4 plus 3 equals, now 64 take away 96 is minus 32, and then we're adding on another 7, so that's minus 25. So our 2 points are 0, 3, and 4 minus 25. And those are the 2 points where the gradients of the tangent are equal to 1, and so where the tangents are parallel to the line that we started out with, that's y equals x plus 5. Let's take another example, and this time I want to introduce the word normal. What's a normal? Well, we tend to think of the word normal in English as mean the same, everything's all right, it's usual. But in mathematics, the word normal has a very specific meaning. It means perpendicular or at right angles. At right angles. So, if I have a curve, let's say that's my curve, and I have a tangent at that point there, then what's the normal to the curve? Well, the normal is at right angles to the curve, so it's also at right angles to the tangent. So there's the tangent to the curve, and this is the normal to the curve. Normal because it's at right angles, perpendicular to the tangent. Okay, if we can find the equation of a tangent, we can surely find the equation of a normal. But there is one little piece of information that we need, and that is, if we have two lines at right angles, what's the relationship between their gradients? So if I take two lines, They're at right angles to each other. And let's say that this line has gradient m1. And let's say this line has gradient m2. Then the relationship between these two gradients, because they are at right angles, is that m1 times by m2 is equal to -1. And that's for lines at right angles. And so since tangent and normal at right angles, we can use this relationship. We can calculate the gradient of the tangent and use this to find the gradient of the normal. Now let's have a look at that in practice. Let's take the curve y equals x plus 1 over x at the point where x equals 2. Let's ask ourselves, what's the equation of the tangent at the point where x equals 2, and what's the equation of the normal? So, first of all, let's establish what the point is. X equals 2, y equals 2 plus 1 over 2, which is 2.5. But thinking ahead, I think I would prefer to have that as an improper fraction, as 5 over 2. That's because I'm going to have to do some algebra with it later, and I'd rather keep it as 5 over 2 than keep it as 2.5. OK, next, we want the gradient at this point x equals 2. So let me just write down the equation of the curve, y equals x plus, and in order to differentiate, be ready to differentiate the 1 over x, I'm going to write it as x to the power -1. And now we can differentiate it. dy by dx is equal to, the derivative of x is 1, plus, to differentiate this, we multiply by the -1, and we take 1 away from the -1 to give us a power of -2. So that's 1 plus, and a minus gives us a minus there. 1 over x to the -2 means 1 over x squared. X is equal to 2, and so my gradient dy by dx is equal to 1 minus 1 over 4. 2 squared is 4, and 1 take away a quarter leaves me with 3/4. So, we have got a point, 2, 5 over 2, and we've got a gradient of 3/4. And so we can find the equation of the tangent. So let's just list what we know. We've got the tangent at the point, and this is 2, 5 over 2, and we know that the gradient at that point is 3/4. So the standard equation for a straight line, y minus y1 over x minus x1 is equal to m, the gradient. And this is x1, and this is y1. So now we can substitute these things into here. Y minus 5 over 2 over x minus 2 is equal to 3/4. Let me multiply both sides by x minus 2. And then let's multiply both sides by this 4. And now if I multiply out the brackets that I've got, 4y, now 4 times by minus 5 over 2. 4 times by the 5 is 20, divided by the 2 is 10, and then the minus sign, minus 10, equals 3x minus 6. And it would be nice to be able to get all these numbers together. So I'm going to add 10 to each side. Will give me 4y equals 3x plus 4. And so the equation of the curve is 4y equals 3x plus 4. And now we need to find the equation of the normal to the curve. Let's say that the gradient of the normal is m2 and that the gradient of the tangent is m1. And let's recall that normal and tangent are perpendicular. And the thing that we said about two lines that were perpendicular at right angles to each other was that if we multiplied their gradients together, the answer we got was -1. Now we do know what the value of m1 is. We do know the gradient of the tangent is 3/4. So if we put that into here, 3/4 times by m2 is equal to -1. So if we multiply up by the 4 and divide by the 3, we get m2 is equal to -4 over 3. And so now we know the gradient of the normal. We also know the point on the curve. That still hasn't changed. That's still the point 2, 5 over 2. So we now want the equation of the normal. Let's just write down what we know. We know the point, that's 2, 5 over 2, and we know the gradient, that's -4 over 3. So our standard equation for a straight line, y minus y1 over x minus x1, is equal to the gradient. And this is the point x1, y1. So now we substitute that in, y minus 5 over 2 over x minus 2 is equal to -4 over 3. Let's multiply up by x minus 2 and by 3. So we have 3 times y minus 5 over 2 is equal to -4 times x minus 2. Multiply out the brackets. 3y minus 15 over 2 is equal to -4x plus 8. Now let's get things together. It's awkward having this -4x here, so we'll add 4x to each side, and we'll add 15 over 2 to each side. So we'll have 3y plus 4x is equal to 8 plus 15 over 2. Now 8 is 16 over 2, so here I'll have 31 over 2. So we'll have 3y plus 4x is 31 over 2. And this 2 is an awkward thing, so let's multiply throughout by 2 in order to get rid of it. 6y plus 8x equals 31. And that's the equation of our normal. Now, when we've got tangents and normals, because the normal is sort of inside the curve, if you like, or passing through the curve, sometimes a normal can actually meet the curve again. And we might be interested to know where it meets that curve. So, the question we're going to ask is, if we have the curve xy equals 4, and we look at the point x equals 2, find the equation of the normal. Where does the normal meet the curve again, if it does? Well, let's have a look at a picture. Y equals 4 over x. What does this look like as a curve? Okay, if we have a very large value of x, say 100, then 4 divided by 100 is very small. So we've got a little bit of curve down here. If we have a very small value of x, say 0.01, then 4 divided by 0.01, 0.01 is 100th. So 4 divided by 100th is 400, very large. So for very small values of x, we've got a bit of curve there. And we can join it up like that. Now, if we take negative values of x, the same thing happens, except we get negative values of y. And so the curve looks like that. Notice we do not allow x to be 0 because we cannot divide by 0. So there is a hole in this curve. There is a gap here at x equals 0. Well, here's the point, let's say x equals 2. There's the point on the curve. There is the tangent to the curve, and there's the normal to the curve. And as we can see, this normal goes through there. So the question is, where is it? Where is that point? So, first of all, let's establish what this point is up here. So we know that x is equal to 2, and that y is equal to 4 over 2 equals 2. So our point is the point 2, 2. Next, we want the gradient of the tangent in order that we can find the gradient of the normal. So here we have y equals 4 over x, which is 4 times x to the minus 1. So I'll differentiate that. dy by dx equals minus 4 multiplying by the minus 1, and then taking 1 off the index, that gets it to be minus 2. So we have minus 4 over x squared. X is equal to 2, and so dy by dx is minus 4 over 4 is minus 1. So, what have I got? I've got the point, 2, 2, and I've got the gradient of the tangent. And remember, tangent and normal are at right angles. So for two lines at right angles, m1 times by m2 is minus 1. I know the value of this, it's minus 1 times by m2 equals minus 1. And the only number m2 can be there is 1. So now I have got, for the normal, I want its equation. I've got the point that it goes through, which is 2, 2, and I've got its gradient, which is 1. So I can write down the standard equation of a straight line. Y minus y1 over x minus x1 is equal to m. This is my x1, y1. And I can substitute those in, so I have y minus 2 over x minus 2 is equal to 1. Multiply up by x minus 2, so we have y minus 2 is equal to x minus 2, and so y is equal to x. And so now we have the equation of the normal, y equals x, and we have the equation of the curve, x, y equals 4. Now, where does this line meet this curve? That's what we're asking ourselves. Where does the normal intersect the curve? At the points of intersection, both of these equations are true at the same time. So that means I can take the value of y, which is x, and substitute it into here. So therefore, I have x times by x equals 4 at these points. In other words, x squared is equal to 4. And if I take the square root, that will give me the value of x. We might think that's just 2, But remember, when you take a square root, you get a plus and a minus. So we have x equals 2 or minus 2. And so if x equals 2, then y must be equal to x, so that tells us y equals 2. Or, and if we take minus 2, y is equal to x, that gives us minus 2. And so our 2 points are 2, 2, and minus 2, minus 2. Those are the 2 points where the normal meets the curve. Notice this is the first point that we started off with. And indeed, when we're doing this kind of question, the point where we started off with always is going to be a part of the solution. So, we've dealt with applications to tangents and normals. We've seen that in order to find the gradient of the tangent, you differentiate, substitute in the value of x, and that gives you the gradient of the curve, and hence the gradient of the tangent. And the other relationship that we found was that a normal was perpendicular to the tangent, and that the product result of multiplying two gradients together where the two lines were perpendicular was minus 1. And that's an important relationship when we're looking at two lines that are perpendicular, as is the case for tangent and normal.